we've got is this project was parsing an archive of bitmapped fonts and extracting all the GIFs out, or all the glyphs rather, out of these files, and then figuring out something to do with those shapes. So this is an example of one of these index tables of bitmap data that was used as a font. This is code page 737 from old IBM machines. This, among many others, is available in this repo that's called Horde of Bitfonts. I have forked it and I've been working with this stuff. I have some resources that I'll link to here at the end. I've kind of gone through and organized this data a little bit as JSON. But basically what it is there's 918 fonts that are kept in these plain text formats that indicate the pattern of the bitmap for each font glyph. So this is not typically how it's handled anymore. Modern systems usually are dealing with a range of different displays. So they have to deal with scalable vector resolution or representations. So these are kind of unique and really not used in modern systems. So basically, the .draw fonts are like this. They didn't have any annotation, but they were there was some variation in indentation, and you can kind of see how that there's a new line versus not being a new line kind of. Anyway, there was a little bit of finagling with that, but that was pretty smooth. The one that caused issues were the YAF fonts, which I believe is yet another font or format. But so basically what we're dealing with here is very, very similar data. But then you had these big chunks that were kind of randomly spread through. They weren't, and I think these were like different modes for different fonts or something. But yeah, so there was some more complicated parser that was involved here. So that here I was mostly interested in the glyphs themselves. So what I did was basically wrote a class for what is a letter in terms of some strings, and then establish like an equality operator and some different things like that. And the next step was to go through and remove all the duplicate glyphs rather. The way I did it for this resource here is just iterating through the list and removing them as I found duplicates. So this is very slow. I mean, we were talking about a 15-minute operation or something like that. But that's kind of immaterial because I can just leave it sit for a minute. The process I'll describe later for automatic duplicate removal with hashing is a cool solution, and that might be something to look into if I were dealing with a problem like this again. It's much faster. So yeah, and again, the same glyph, if it appears in multiple fonts, it's not interesting for this application. So what we're doing here is we're trying to remove anything that doesn't fit this definition of a glyph. It's an n by m rectangle for some integers n and m, and it can only have two different characters. So that indicates the the on and off states. And then basically I went through and removed all the letters that don't match. And there was just some crap that was captured in there, and the data wasn't good at all. So massive reduction in the number of entries, went from almost 900,000 to 55,920. And just so we can kind of have some context here of what that actually looks like. I have this as a dump from a modified version of STB rect pack, which is it basically packs rectangles. And so what I did here was basically every distinct glyph. I have an entry here, and you can see, like, the different collection of fonts, and how there's some pretty unique stuff in here, like card symbols, astrological symbols, different languages, outlines, and graphical symbols for tables and things like that. So it's a pretty widespread. But so that's all the distinct glyphs. After processing, the initial data was almost 89 megabyte. Again, that's a lot of text, and but it has everything broken out by font. If you were actually interested in reconstructing fonts themselves, or you wanted to use them as such, that might be useful for you. Then the version that I'm using in Voraldo is just all the distinct glyphs, numbered, not labeled in any way. So that's much simpler to go through, I guess. And here at the end, I'll kind of walk you through how you can use this data. It's very easy. So two applications that I've done for this, rather with this data, random stamping of these glyphs in the space. And that's pretty intuitive. They're just kind of there. And that was just kind of a proof of concept, looking at what I had. Then the next thing I did was this thing, I don't know, I'm calling it a spaceship generator, but that's, it's kind of random symmetrical structures generator that uses some small set of rules that are randomly applied to create these symmetrical objects. And just as an aside, this is one I made this morning, experimenting with some upscaling stuff. So basically what this is the render texture in the program is set to 1/3 of the resolution on each linear dimension. And then we're taking multiple jittered samples per pixel, or per texel rather, in that render texture. So what that means is basically I'm offsetting the ray origin a small amount each sample. So after 10 samples, I have this kind of, essentially I've accumulated some amount of MSAA, and then I've got this upscaled to 1080p, and I'm pretty happy with how the renderer handles that. This is something that's functional on a laptop from the early 2010s. I have a 2012 ThinkPad that I use sometimes. It's an X240. I mean, it's just got an Intel integrated graphics chip in it, and it will run this. So, pretty cool. So how this works, we're using a hash map, so a standard unordered list with IBEC3 keys, and just a simple RGBA for the contents. And what this gives you is automatic duplicate removal. So when I'm writing back to the same IBEC3 location, I'm overwriting the data that was already there. So this does a couple of things that are very cool. Negative indexing of voxels, just as a natural extension of how numbers work. You can just have IBEC3 keys that have negative values. So that's very cool. And the container only holds voxels that are occupied, so it scales well for this type of manipulation. So the list of operations, and there's one that's not listed here, but it's establishing the bounding box. Relatively self-explanatory. It's basically iterating through every entry in the hash map and looking at the minimum and maximum value on each axis. So flip is basically picking one of these axes and flipping it, right? And this is for interaction with the other operations. Not necessarily very interesting by itself, but for example, flip and then mirror and then flip again, you know, and then do something else, right? And it might start to add up to something more interesting. or mirror and then flip and then mirror. So mirror is basically like I take the, you know, the bounding box and I align it to 0, right? I move it up so that it's butted up against the. Essentially, it's not exactly normalized, but it's like it's offset so that there's no negative indices. And then I'm picking one of the axes, X, Y, or Z, and then I'm doubling the data about that axis. So I'm basically adding negative, you know, for iterating through the whole map, and then adding entries that have negated coordinate on that axis, whatever the selected axis is. Stamp is same as the random stamping. And that's up to 12 glyphs are just stamped at a random position, and it's a Gaussian normal distribution. So it's kind of right at the center of the bounding box, but like there's some spread about that center. And that is, it overwrites just by virtue of when I write to the same key location, I'm going to overwrite the value that's there. And then there's this other operation, shave, which is basically removing some amount of, and this is another one that interacts well with the flip operation. It basically goes through and says, okay, after aligning the bounding box here to 0, 0 to some maximum on each X, Y, and Z, I'm going to go through and remove everything that's above a certain value that I picked between 0 and the size of the bounding box on that axis. So, you know, basically chopping off some of it. So you see some results here. Be happy to answer any questions that anybody has about it. And then if you guys would like to see, I can do a short demo of what this looks like.
Is your write-up published yet?
This one is not. I'll have it done probably.
Okay, yeah, because I tried going to the link that was in the slides and I got a 404.
Oh, sorry. Yeah, you might have to put like index.html there. If you just go to the root directory, jbaker.graphics, you can get there pretty easily. Sorry, it's not the greatest website design. Yeah, so the constant time duplicate removal. Yeah, I think, or rather, yeah, big O of n rather. I think that's a good point. Yeah, that's one thing that I mentioned earlier. But yeah, like I think that if I were approaching this again, I would have done that. But I got into that later, I guess. I found out about standard unordered map for this kind of application, talking to some people on the graphics programming Discord. One other thing that I have here is all the glyphs, but with each one outlined with a different color. This is on the write-up for just the collected fonts. But yeah, so this is just kind of showing what the footprint is. Yeah, so they're an Apple symbol and kind of Gothic lettering, but yeah, all kinds of stuff. Yeah, so does anybody have any questions other than that?
Yeah, you want to show us a quick demo?
Yeah, absolutely.
I'd like to see this, in action.
Yeah, so I'm running it at a very low resolution right now. This is the upscaling that I was messing with this morning. So basically, we're running at 640 by 360 and then upscaling to 1080p. So I would welcome any criticism on how that looks. I'm honestly pretty impressed with it. I think it's valid-ish, something, I don't know. So if I clear that out and then I go in here to the spaceship feature, right? Well, no, that's not it. Yeah, so I generate a random palette and tell it how many operations I want. This scales that Gaussian normal distribution. And then I can set like, this scales the glyphs. Right, one is each pixel on the glyph is a 1 by 1 by 1 voxel. If it's 2, then it's 2 by 2 by 2, whatever. And then I can also set a thickness. So that's, maybe I want to go to like 45 or something. So I'll make some like long tube shapes. And then anyway, so I just tell it go, and it might take a second, but then it generates this kind of shit in here. And you can just tell it to go again, and yeah, so if I set it to like 6 operations, it's faster. But yeah, it's kind of random because, random number of things happening. So maybe I thought this was something kind of cool, and I wanted to I'll just kind of show you what the workflow with this thing, if you want to make like weird shapes and stuff. I don't have anybody really testing this, but if anybody would be interested in doing so, definitely talk to me about that. So yeah, here masking by the alpha channel. So I'm setting a value that's high, and then I'm going for a spread that's basically the full range. So, and I'm telling it I do want to use the alpha channel as a masking criteria. Then I tell it how much I want to mask. So I'm going to set that like not quite full. And then okay, so that's masked. Okay, and then I go in here and I tell it I want to blur and respect the mask. And set some radius and do a blur. Right, and so what that does is it keeps the value in there. Mostly because I didn't fully mask it, but anyway, and then, and this kind of gives it a little bit more definition or whatever. It's not just a flat whatever. And then, so if I clear this out to some flat color for lighting, that's just constant value all through for the light. And then I can do it's not a good global illumination model. I'm working on that actually. I have some ideas on that, but then actually, well, I'm not going to do that. Also going to do this. So this is with more extreme perspective scaling. So you can see more foreshortening when I rotate. Yeah, and so we'll just go ahead and do some lighting really quick. And so this is color, and then the decay parameter is like how the alpha channel is used. So it's raised to a power. The normalized value of the alpha channel is raised to a power to give you more usable range. And so it's like we're getting down towards 1, things become like a hard limit very fast. But when you raise it higher, you get more penetration. Those value that curve gets lower values kind of get squashed down. Anyway, so with the directional lighting, it kind of goes through and it tries to, for every voxel, it looks at how much occlusion it has, just all the way through the volume in that direction, rather the reverse of that direction. And so that's essentially how much the light is attenuated on the path between the voxel and the light source. And so that gives you these that full volumetric effect here. So I'm just going to do this, unmask everything. Again, using full range of the alpha, so I'm doing everything that's even vaguely opaque, masking, and I'm going to draw over it with something that covers the space. So we're going to do orange that has like an alpha value of 9. And so drawing that, then that fills in the negative space. But because I masked it before I did that, I still have that contents retained. So if I clear the lighting and then start again, I can show you point lights now. And if I put that right at the center and just kind of screw around with sliders, then I can, well, that clipped really bad actually. Okay, and this is actually a problem I just found today. That clipping doesn't reset. There's a problem with nans in my accumulator. So that black square just stays there. Anyway, I've got to restart it. But yeah, so general lighting is I don't know, pretty snazzy. You get the volumetrics and stuff that bleeds into the stuff that doesn't have where the alpha value is kind of lower. And so you get that kind of cool, with the XOR, I think it's really cool. And there is actually, Jaker, I think you mentioned here now, nans in the accumulator. Yeah, exactly. Yeah, but the ghosting is actually a real problem that is there, but it tends to resolve itself within 12 to 15 frames is generally, and I keep a history of like 10. So not a history, it's like, my blending is really weird. I was actually talking to somebody about that earlier today. It's actually scaled with blue noise per pixel, and that's actually a really strange approach. So, I guess I'm not sure exactly what I was thinking when I was implementing that, but a lot of the parameters are actually, so the rate origin, I think I was just using blue noise in a lot of different places. The ray origin, right where your eye is for every pixel, is jittered a small amount within index. Like, all right, so you think about like integer indices for every texel. It's jittered within that integer with a 0 to 1 floating point number on the X and on the Y, and then when it's traversing on the Z, the samples are now also jittered by blue noise. So I can get away with fewer blue noise samples through the volume, but I've interestingly, it's gotten rid of the aliasing that I was having, where the back face would show through on the front face. That was actually a pretty sizable issue for a while. Was that you could, like, when you had a partially transparent volume, you'd see this like weird shadow on the back face. But anyway, more to the point, I guess, we look at some more spaceships. I have a couple that I saved that I really liked. The copy and paste functionality would be really handy for this type of stuff, but it's not implemented yet. I should probably take the tab out. Yeah, so we'll fix the lighting. This is the one that I was messing with this morning. And so if we look at some maybe more yellow type of lighting, And then there's also a neighborhood-based ambient occlusion that basically looks at the alpha in the neighborhood and then kind of tries to decide how much ambient occlusion it would receive from a neighborhood that's occupied that much. Yeah, sorry, I've only got the one monitor set up right now, so if, feel free to ask questions a lot if you'd like. Anyway, yeah, the ghosting is relatively subtle. It's you only notice it a small amount, and yeah, basically what happens is every time the data changes, right? So any time a rotation or contents change, whatever, there's a whole set of operations that force a reset. But basically, there's a counter that counts down from some size history or whatever. And so once it has static data, it's going to continue after that for that many frames blending. So that's kind of how I get away with doing stuff like this in real time, I guess, is kind of keeping a render texture and then